Hi, Rajan this side. So today we will be discussing the problem asked in LeetCode Weekly Contest 423. So let's start with the first problem. So the first problem says that you are given an integer array num of size n and an integer k, and you have to determine if there exist two adjacent subarray of size k such that both the subarray are strictly increasing, right? This is the problem. So you have to return true if you find two subarrays which are adjacent of size k and both are strictly increasing, right? So this is a pretty straightforward question. So what we can do, so we are given an array, right? We are given an array of size n. What we can do, we can start doing the brute force way. For each of arrays, like subarrays of length 2k, divided into two parts. The first subarray consists of first k element. The second part should contain next k elements. Just check if this subarray is increasing, this subarray is increasing, and this subarray is increasing. Once you do that, just check if both the subarrays are increasing. If you find any of subarray of size 2k such that the first half is increasing and the second half increasing, then just return true, right? So the time complexity for this case would be n into k, right? And in the problem it says that n is less than or equals to 100, so n into k would pass, right? So it's a brute force. So let's quickly look at the code now. So this is the code. You are given an array num, and so what I did, so I'm going through all possible subarrays of size 2k. Then I created two subarrays of size k and k, so for the first half and for the second half. So your first array would consist of elements from index I to I plus k minus 1, and the second subarray would consist of elements from index I plus k to I plus 2k minus 1. So I created two subarrays. Then I checked if both are increasing or not. So to check if both the subarrays are increasing, what you can do, so each element, so like if if the given array is increasing, means that every element in that must be greater than its previous element. So I just check that if my current element is greater than my previous element. If all the elements are greater than its previous element, it means that both the arrays are increasing. So if both are increasing, just return true. So I just returned checked here if both subarrays are increasing. If they are increasing both, then just return true, otherwise false, right? This is the second problem asked in the LeetCode contest 423. This is pretty much similar to the first one. There's a minor difference, so let's see what is the difference. So here you are given an array num of an integer. Now you have to find the maximum value of k for which there exist two adjacent subarray of length k such that both the subarrays are strictly increasing, right? This is similar to the first problem. In the first problem you are given k and you have to check whether there exists a subarray of size 2k, where the first half and the second half are increasing, right? But here you have to find the max value of k such that you find a subarray of size 2k where the first half is strictly increasing and the second half is strictly increasing, and you have to return the maximum possible value of k. So let's see how we can approach this. So let's take one example, 4 1 2 and 3. So for the given array we will create another array which will store one information. Let's name it increasing until. What it will store, for each index it will store what is the leftmost index from where the current subarray is increasing. For example, for 3 it is increasing, so for 3 it is increasing from index 1. So this is 0 1 2 3 indexing. So this current 3 is increasing starting from index 1, so we will store 1 here. For 2 this subarray is increasing, for 3 this subarray was increasing, so I stored index 1 because it is increasing starting from index 1. For 2 information is still 1, for 1 1, for 4 it is 0, right? Let's take another example to understand it. Let's take 4 5 1 4, and let's say this is 7, and then 6 0 1 2 3 4 and 5. So your increasing until array would be, for 6 it is increasing from 6 itself because the previous element is more than the current element, so this will be 5. For 7 it is increasing from index 2, right? 1 4 and 7, because before 5 is more than 1, so this subarray won't be increasing. So 1 4 7 is increasing, so I will store 2 here. Same for 4 it will be 2, for 1 it will be 2, for 5 it will be 0 because starting from 0 it is increasing, and for 4 it is 0. So we will create this array. Once you do that, your problem will be solved, right? So the first job is to create this array, increasing until array, and then what we will do a binary search here, because we know that for a like let's say for a given k, if I claim that I have found one subarray of size 2k such that first half of k elements and the second half of k element both are increasing, I can prove that it is always possible to found a subarray of size k minus 1 in such a way that you create an array of size 2k minus 2 where the first k minus 1 and the second k minus 1 will be increasing. How? We know that this is possible. For k possible, I claim that k minus 1 is also possible. Let's see how. We know that this is increasing and this is increasing. Why not remove the first element here and the last element here? Then this array will be a good subarray where the first, so once you remove the first element, the remaining element will be k minus 1. Once you remove the last element, it will be k minus 1, and both are increasing, so it is always possible. For k minus 1 is possible, so it's a monotonic behavior. So and this is the requirement to solve this problem using binary search. So we can solve this problem using binary search. Let's see how we can write code for it. So this is the code. I created this increasing until array. What I did, for each element I kept on going like until you are getting a increasing subarray. Then I updated the index value for each of them. So this process is to find to build the this increasing until array. After that I did a binary search here, so the minimum possible value of k could be 1 and the max value possible could be n by 2. I found the mid element here. Then I checked. So what I did for, so now I'm checking if it's possible to get this mid as a k. So I'm going through all possible subarray of size 2 into mid, where the first half contain mid element and the second half will contain mid element. I created first subarray of size mid from I to I plus k mid I plus mid minus 1, and the second half would consist of element from index I plus k to I plus 2 into mid minus 1. This is mid. And then I just checked. So see, to check whether the first subarray of size mid is increasing or not, so this is my left index and right index for the first subarray, and this is my left index and right index for the second subarray of size mid. I checked if the increasing until array of the right index is less than or equal to L1, the left index. If this is possible, it means that this is a strictly increasing subarray. Same for the second subarray. If both are increasing subarray, it means that you can get. So this OK will tell you if it's possible to get this mid as a k, as a valid k or not. So if it is a valid k, like update your answer. And now since this is a valid k, then there is no need to go for lower one, because I just told you earlier that if it's possible for k, so k minus 1 is also possible. So go to the right half of first space. So now so earlier your search space was L to R, but now it has changed to mid plus 1 to R. And if it's not possible, then your first in a first half, because if k is not possible, then k plus 1 is anyway not possible. And at the end return answer. So the time complexity for this case is n log n. The time complexity is n log n. So this is the third problem which is asked in the contest. So it says you are given an integer array, and there is a term called good subsequence. Like the good subsequents are those subsequents where the absolute difference between two adjacent integers are exactly 1, and you have to return the sum of all possible good subsequents, and by modulo 10 to the power 9 plus 1. So let's look at the first test case. So like we know that if there is an array of size n, so there are 2 to the power n number of subsequents possible. So for this case we have 8 number of possible subsequents. Out of them, the only these 6 are a valid subsequent, because if you look at the difference between any two adjacent elements are exactly 1, right? So so let's see who are those subsequents which are not good subsequents. So if you look at 1 and 1 is another subsequence, but this is not good because the difference between two adjacent elements is 0, but it says the difference between any adjacent elements will be exactly 1, right? So let's see how we can approach this problem. This problem can be solved using dynamic programming. So I'm going to discuss the dynamic programming approach which I have used in the contest. So we know that we are given an array. This is my array, ARR, right? I will solve this problem using DP. So let's see the definition of DP. Your DP of I is sum of all subsequents that ends with element I, and similarly count of I will be count of all subsequents ending with element I. So in DP, how we approach a DP problem is that we first look at what is important so far, what information which you can store in somewhere so that you can use that information to solve the bigger problem. If you so what we can do in the DP, we build from smaller sub problem, and we keep on building them in order to get the result for the bigger problem. So if you store information for those subsequents which ends with element I, we can use this information to make like other decisions. Like for example, we know that if my current element is I, the next element could be either I plus 1 or I minus 1, because like in the problem it says that the absolute difference between two adjacent elements should be 1. So if we know the information of I, we can build for I plus 1 and I minus 1, right? So what you are doing, you are using this stored information for a smaller sub problem to solve for the bigger problem, right? So let's say my current element is I, and we know what is count of I minus 1. Let's say count of I minus 1 is 3. It means that there are 3 subarray which we have found that ends with element I minus 1. To get a good subsequent, what we can do, we can append I to any of them, right? We can append I to any of them. Once you do that, what will be your count of I? Your count of I will be incremented by count of I minus 1, because earlier we have 3 number of good subsequent which was ending with index I minus 1. Once you append I to each of them, now the count of I will be incremented by that much good subsequence, right? And what will be your DP of I? So DP of I says that it stores the sum of all subsequent that ends with element I. So this DP of I will be the sum of all these numbers in the good subsequence, right? So let's see how we can update the DP of I value. your dp of I will be incremented by dp of I minus 1, which was the previous sum of all good subsequent that ends with element I minus 1, plus you are appending I to each one of them, so which will be count of I minus 1. These were those subsequent which the count of those subsequent that ends with element I minus 1, and you are appending I to each one of them. So this way you will update your count, like count of those subsequent that ends with element I, and this way you will update the dp value of those good subsequent that end with element I, whose previous element is I minus 1. The same concept is apply if your previous element was I plus 1, right? So we will use this concept to solve this problem. So this is your recursive approach, like the recursion formula to solve this TP. Let's see how we can code it. So this is the code of third problem. I like the problem says that you have to return answer modulo 10 to the power 9 plus 7. So I created a mod variable, and I'm taking long int to be on a safer side. So n is your size, m is the maximum element in the given array. Then I created a dp array of size m plus 1 because the max possible number could be m. So your dp of I will actually store the sum of all good subsequents that end with element I, and count of I will store the count of all good subsequent that end with element I, right? Then what I'm doing here, I'm going through each element in the given array. So there are two cases. Either you append your current element x to the previous any good subsequence that ends with either x minus 1 or x plus 1, or you can create a new subsequent that consists of just single element, which is that element itself. So this is the case when you created a single good subsequence that consists of just one element. In that case, your dp of x would incremented by just x, and your count of x is going to be incremented by 1, right, for subsequent this one. Now I'm taking care of two cases, the like whether the previous element is x minus 1 or the previous element is x plus 1. So this is the case when your previous element is x minus 1. So just check if it is greater than or equal to 0, and just check if you have found any good subsequent that ends with element x minus 1. If you do that, then just update your dp of x and count of x as discussed in the explanation part. Your dp of x is incremented by dp of x minus 1 plus count of x minus 1 into x, and similarly for count of x. And same applies the same concept is applies for when your previous good subsequent ends with an element x plus 1. At the end, just modulo it with the with 10 to the power 9 plus 7. And now here what I'm doing, I'm going through all the possible number, and I'm checking that what are the sum of the good subsequent that ends with element I, and I start from 0 to 11, and at the end return answer. So this is the explanation of first three video. Like I'll post the solution of fourth video soon. I have written the code, but I couldn't got the accepted solution for fourth one. So yeah, like if you find the video helpful for like the first three explanation helpful, please like and subscribe to my channel. Thanks for watching.